Hello everyone. In the last session, we discussed about the kinetics of step growth polymerization. In this session, let us study about the radical chain polymerization. First, let us know what is chain polymerization. So, this chain polymerization is a process of self addition of the monomer molecules to each other very rapidly through a chain reaction. Here, there is no formation of byproduct. What type of compounds undergo this chain polymerization? The compounds containing reactive double bonds undergo this type of polymerization. So, the compounds like olefins are nothing but alkenes, and vinyl compounds. Vinyl compounds means the compounds with the general formula CH2 double bond CH(X). These are known as vinyl compounds. This group CH2 double bond CH, this is known as vinyl group, right? So these type of compounds undergo this chain polymerization reaction, and this is also known as addition polymerization. And the polymers such as polyethylene, polyvinyl chloride, that is PVC, polystyrene, etc. are formed by this chain polymerization reaction. Then, this chain polymerization consists of three major steps. The first one is initiation, and the second step is chain propagation, and the third step is termination. So these three steps are common for all chain polymerization reactions. This process of chain polymerization can be brought about by different mechanisms. Depending on that, we have three types. One is free radical polymerization, second one is ionic polymerization, and the third one is coordination polymerization. Now, let us concentrate on free radical chain polymerization. This is also known as radical chain polymerization. Here, the initiation of polymer chain growth is brought about by free radicals. What are these free radicals? Free radicals are the reactive species with an unpaired electron. Due to this presence of unpaired electron, these are highly reactive, and they always want to pair up with another electron in order to attain stability, and it is represented as R dot. So this dot represents the unpaired electron, right? Yes. Then how to get these free radicals? These free radicals are obtained from the initiators. So these initiators are the thermally unstable compounds. When we supply energy to these compounds in the form of heat, light, or catalysts, they undergo homolytic decomposition to give free radicals. The compounds such as azo compounds, peroxides, peracids, etc. are mainly used as initiators. What happens here is, say for example, if you take a molecule like this. So, when you supply energy in the form of heat, light, or catalysts, it undergoes homolytic cleavage. ಹೋಮೋಲಿಟಿಕ್ ಕ್ಲೀವೇಜ್ ಅಂದರೆ ಏನಾಗುತ್ತೆ, ಇಲ್ಲಿ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಇದೆಯಲ್ಲ, ಸೊ ದಿಸ್ ಕೋವೆಲೆಂಟ್ ಬಾಂಡ್ ಗೆಟ್ಸ್ ಬ್ರೋಕನ್ ಡೌನ್ and the fragments formed will have an unpaired electron. So this is the homolytic decomposition, and the products obtained are the free radicals. Then these free radicals are used up to initiate the chain. So that step is known as initiation. In this step, the free radical obtained from the initiator attacks the double bond in the monomer molecule. See here, this free radical attacks the double bond. So this is the vinyl compound. We are taking an example of vinyl compound, and here there is a carbon-carbon double bond. You know that in the carbon-carbon double bond, one pair of electron exists as sigma bond and the other pair exists as pi electrons, right? So what happens, I will represent this pi electrons as 2 dots, right? One bond andre 2 electrons anta artha alva, and these pi electrons are not very close to the nucleus, hence they are loosely held and are susceptible to the attack by free radicals. So ಇಲ್ಲಿ ಏನಾಗುತ್ತೆ, these free radical attacks the pi electrons and form bond with one of the pi electron, and the other electron is transferred to the other end of the molecule. So ಇಲ್ಲಿ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂಮೆಂಟನ್ನು ಈ ಥರ ತೋರಿಸ್ತೀವಿ. ಸೊ ದಿಸ್ ಇಸ್ ಹಾಫ್ ಡೆಡ್ ಆ್ಯರೋ, ಸಿಂಗಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಮೂಮೆಂಟನ್ನು ಈ ಆ್ಯರೋಯಿಂದ ತೋರಿಸ್ತೀವಿ. ಸೊ ದಿಸ್ ಅಟ್ಯಾಕ್ಸ್ this one, and the two together form a bond like this, and this electron shifts over to this carbon. See here, right? So in this initiation step, the free radical attacks a monomer molecule and adds the monomer molecule to itself, and while adding simultaneously transfers the radical site from itself to the monomer unit ಅಲ್ವಾ. ರ್ಯಾಡಿಕಲ್ ಫ್ರೀ ರ್ಯಾಡಿಕಲ್ ಮೇಲಿದ್ದಂಥ ಅನ್ಪೇರ್ಡ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇವಾಗ ಎಲ್ಲಿಗೆ ಹೋಯಿತು, ನಮಗೆ ಮಾನೋಮರ್ ಯೂನಿಟ್ ಮೇಲೆ ಹೋಯಿತು. therefore active site is transferred from radical to monomer unit. So this is the initiation step. Then the second step is propagation. So in this step, the radical site, that is unpaired electron at the first monomer unit, attacks the double bond of a fresh monomer molecule. So what happened? The second monomer unit is linked up with the first, and the radical site is transferred from the first monomer unit to the second. See here, so this is the radical site on the first monomer alva. So this gets linked up with the second monomer unit, right? So ಇಲ್ಲಿ ಈ electron gets shifted to the this carbon. Here you can observe that the chain still contains a radical site alva. ಇಲ್ಲಿ ಇನ್ನೂ ಒಂದು unpaired electron ಇದೆ. So it is ready to attack another fresh monomer unit. So it attacks the third monomer unit. See here, this unpaired electron attacks the pi electron of the another fresh monomer unit, and the remaining electron gets transferred to the next carbon. So you will get a structure like this. So this also contains the radical site, so it can attack another monomer molecule. Likewise, it continues. So this process of successive addition of monomer molecules to the growing chain one after another is called as propagation, and that growing chain is represented by this structure. So ಇಲ್ಲಿ ನೋಡಿ, this is the monomer unit. N monomers combine to form this long chain polymer, and you can also represent it like this. ಇಲ್ಲಿ n monomer units ಅನ್ನು ವೇವಿ ಲೈನಲ್ಲಿ represent ಮಾಡಿದ್ವಿ. So this still has the active site on it ಅಲ್ವಾ, ಅಂದರೆ radical site, unpaired electron ಇದೆ. So this propagation continues till the termination, or till there is no further monomer left for attack. Then the final step is termination. In this step, the addition of monomer units to the growing chain is stopped and the growth of the polymer chain is arrested. This can occur by any of the following. First one, termination by coupling or termination by disproportion. Let us study the termination by coupling. When the two growing chains collide with each other, the coupling of the lone electron present in each of the chain to form an electron pair results in arrest of the chain growth. See here, this is one growing chain with an unpaired electron, and this is another growing chain with an unpaired electron. When these two chains collide with each other, what happens? These unpaired electrons gets paired up and form a bond, right? Therefore, this longer chain will be formed. Here you can observe there is no active site, right? So polymerization further continue ಆಗೋದಕ್ಕೆ ಆಗೋದಿಲ್ಲ. This is how the chain gets terminated here, right? This is the termination by coupling of two growing chains. Then the second method is termination by disproportionation. Here one hydrogen atom from one growing chain is abstracted by the other growing chain and utilized by the lone electron for getting stabilized, while the chain which donated hydrogen atom gets stabilized by the formation of double bond. Let us see the example. See here, here also we have considered two growing chains. So this free active site on this growing chain abstracts the hydrogen from this chain. So hydrogen ಹೇಗೆ ಬಾಂಡ್ ಆಗಿರುತ್ತೆ ಕಾರ್ಬನ್ಗೆ, ಲೆಟ್ ಮೀ ರೈಟ್ ಇಟ್ ಲೈಕ್ ದಿಸ್. ಒಂದು ಬಾಂಡ್ ಅಂದರೆ ಎರಡು ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ಇರುತ್ತಲ್ವಾ, ಸೊ ಒಂದು ಹೈಡ್ರೋಜನನ್ನು ಈ ಥರ ಬರ್ಕೊಂಡಿದ್ದೀನಿ, ರೈಟ್? ಸೊ ದಿಸ್ ಅಬ್ಸ್ಟ್ರಾಕ್ಟ್ಸ್ ಅಂದರೆ it forms bond with one of the hydrogen. So ಏನಾಯಿತು, ಈ ಸ್ಟ್ರಕ್ಚರ್ ಬರುತ್ತೆ. ದೆನ್ ಇಲ್ಲಿ ಇನ್ನೊಂದು ಎಲೆಕ್ಟ್ರಾನ್ ಉಳ್ಕೊಂಡಿರುತ್ತಲ್ಲ, ದಟ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೋಸ್ ಹಿಯರ್ ಆ್ಯಂಡ್ ದಿಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಗೋಸ್ ಹಿಯರ್. ಸೊ ಇಟ್ ಫಾರ್ಮ್ಸ್ ದ ಪೈ ಬಾಂಡ್, ದಟ್ ಇಸ್ ಇಲ್ಲಿ ಡಬಲ್ ಬಾಂಡ್ ಫಾರ್ಮೇಷನ್ ಆಯಿತು. So this is the termination by disproportionation. So this is how the radical chain polymerization reaction takes place. In the next video, let us learn the kinetics of radical chain polymerization. Thank you.